Hi guys, today we are going to look at the first part of our last lesson in Unit 13. We're going to split it into 2 days, and today we're going to look at how to evaluate reciprocal trigonometric functions, and tomorrow we'll look at how to graph them. So, first of all, we need to remember this word reciprocal. So hopefully you remember this word reciprocal. We did reciprocal functions, and we've been using this word off and on throughout the whole year, but a reciprocal of a function or of a fraction means to flip the fraction. It means flip it. So we can find the reciprocals of the 3 trigonometric functions that we have learned so far. Each one has a reciprocal. So the reciprocal of sine is cosecant, the reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. Now I think that tangent and cotangent are the easiest to remember because it's just the word tangent with co in front of it. And then with secant and cosecant, I don't know why they did it this way, why it's not cosecant with cosine or secant with sine, but it's, I just remember that the co does not go with the co. So like secant does not have the co at the front that cosecant does, but it does go with cosine. So just remembering that only one of the words can have a co with it. That sounds silly to say it like that, but that's the best way that I found to remember it. It's important to also notice that their domains do not include real numbers, theta, that make a denominator 0. We are still holding to the rule that the denominator cannot equal 0, because if it equals 0, then that means that we would be dividing by 0, which is not possible. And so that will really come into play more. It'll come into play a little bit today, but especially tomorrow when we go to graph them. So, for example, suppose that sine of theta is 15 over 8, and then it says find the cosecant of theta. Well, the cosecant is just the reciprocal of the sine function. So if sine is this, that means that cosecant of theta is 15 over 8. And that's it. All I have to do is flip those around. I just want you to see that all we're doing is flipping those around. Now for the next one, we haven't really done anything yet with the calculator and how to find function or trig functions or trig values in the calculator, but we are going to do that here. So what we're going to do is we know that cotangent of 55 degrees should be equal to 1 over tangent of 55 degrees. Now, what I can do is find tangent of 55, and I'm going to round to the nearest hundredth. So when I do that, I get negative 45.183. All right, so when I divide 1 by that, I would get negative 0.022. If you're doing something in the calculator, it is important to note that you are in degrees and not radians. Oh, I think I was in radians actually. So let me double check that answer as I'm saying it. I'm like probably messing it up. Oop, I did. Sorry, so that was in radians, but I want to be in degrees because it's not 55 radians, it's 55 degrees. Sorry, guys. So we would have 1.428. That makes way more sense. And so then if I do 1 divided by that, I would get 0.70. Round to the nearest hundredth. This is the nearest hundredth, so that would be my final answer. Sorry again, my bad. All right. So let's review the unit circle and fill in the coordinates of the main values. Really what I would say at this point, this is where in class I would actually get out the unit circle and have us fill it in. But this is where you're going to need to get out your unit circle. Hopefully you still have that because we're still in Unit 13. And that's going to come in really handy for this unit or for this last lesson in finding values. So we can use what we know about reciprocal functions in the unit circle to find exact values for the reciprocal trigonometric functions. So if I said find the exact value of each of the following, here's what we could do. For secant of 60 degrees, that would be the same as saying, okay, what is 1 over cosine of 60 degrees? Well, cosine of 60 degrees is where the x, or it is the x value of at 60 degrees. So if I look at my unit circle, I've got my 30, my 45, my 60 degree angle. So I'm looking at this point and I'm looking at the x coordinate of that. And the x coordinate there is 1/2. So I'm saying it's 1 over 1/2, which would give me 2. So the secant of 60 is 2. But we can actually do this a little bit different. Instead of, well, actually, let's do cotangent first, and then for cosecant I'll show. So cotangent of 45 degrees is going to be 1 over tangent of 45. Now, we haven't talked a whole lot yet about how to find tangent values, but really what we're doing with tangent, and remember that at 45 degrees, it's radical 2 over 2, radical 2 over 2. What we're doing for tangent, and this is very important, you might want to make a note of this, is that the tangent, well, we know that, hold on, back up, sorry. Cosine is equal to x, sine is equal to y, and tangent is equal to y over x. We get the tangent value by dividing the y coordinate divided by the x coordinate. So if I take the y coordinate of 45 degrees divided by the x coordinate, I'm going to get 1 over radical 2 over 2 divided by radical 2 over 2. Now, you might look at that and go, oh my goodness, this is the worst thing that's ever happened in my life. But in this case, it's not too bad, because if I have radical 2 over 2 divided by radical 2 over 2, it's the same thing in the big numerator as the big denominator. And so really, those are going to cancel out and just equal 1. So I've got 1 over 1, which equals 1. So the cotangent of 45 degrees is 1. All right. So the unit circle comes in handy because if I'm looking at the cosecant of 30, I can say, okay, cosecant of 30 degrees is 1 over sine of 30. And when I look at this one, I get radical 3 over 2, comma 1/2. The sine value is the y coordinate. So I would be saying it's the same as secant of 60. It's 1 over 1/2, which equals 2. So what I would say then is, if you need to write it out like this to remind yourself what you're doing every time and then show your work, that's fine. However, as you get more comfortable with this, I hope that you'll be able to look at cosecant and just say, okay, cosecant of 30 degrees, I know that that's 1 over sine. And my sine value is 1/2. So maybe even skipping just kind of this stage right here, if you can, but 1 over 1/2. I think it's still wise to show your work like that, especially as we get into problems that have radicals. But this is how we would show the value. So if we went the opposite way, if we were doing negatives, remember that in a unit circle, ooh, that might be the worst circle I've ever drawn in my life. Remember that in a unit circle, when we're going negative, it's going clockwise. It's going the opposite way is when we go positive. So secant of negative 45 would be secant of, I'm going to continue to show my work, but I'm hoping that you're seeing the value of the unit circle here. It would be 1 over cosine of negative 45. So at negative 45 degrees, it would be this value right here. So that is radical 2 over 2, comma negative radical 2 over 2. And then the cosine is the x-coordinate, so it's this one. Now, we cannot leave a fraction within a fraction. Oops, that's not your homework, sorry. We cannot leave a fraction within a fraction, and we can't leave a radical in our answer. So I'm going to show my work for this. What I'm going to get is 1 divided by radical 2 over 2. So that would be, change the divide to multiply, and then do the reciprocal of the denominator. So I'm going to end up with 2 over radical 2. Rationalize my denominator, and I get 2 radical 2 over 2. but I can simplify a little further. I've got these 2's on the outside. I can't touch the 2 that's under the radical, but this is in front and this is below, so those can cancel out. So my final answer should just be the square root of 2. Now, this seems like a lot of work, but again, as we start to do this more and more, kind of like we did when we were filling in the values of the unit circle, it seemed like a lot to have to figure out, is it to try to find the value of 1/2 to find the value of radical 3 over 2. This is going to start to make you say, wait a second, these values are going to come up being the same thing. Anytime there's a radical 2 over 2, if we're doing the reciprocal, it's going to be radical 2. If you need to show this work every single time, that's fine, but I'm hoping that you'll start to see the patterns that are going to start coming up here. So cotangent of -180, that would be going all the way around here. That would be actually what I drew here. I wasn't doing that intentionally before, but it works out. 180 degrees, so that would be here. And this point is -1, 0. I moved left -1 and up 0. So that means that it's 1 over the tangent. Well, remember that tangent is y over x, so it would be 0 over 1. So when I do cotangent, I'm saying that it's I'm doing 1 over the tangent, which was 0. But I cannot have a 0 in the denominator. If I do 1 divided by 0, I'm going to get an undefined answer. And actually, this is going to come up tomorrow in our graphing. We are going to see what happens when we have a value of 0, because we have these 4 main points that do give us values of 0 in either the x or the y. So we'll play around tomorrow with what happens when it's undefined and what does that look like graphically. All right, last one. Cosecant of -60. So -60 would be here. And my values are going to be 1/2 negative radical 3 over 2. So I've got cosecant of -60 degrees is equal to 1 over sine of -60, which equals, the sine is the y-coordinate, so I've got 1 over negative radical 3 over 2. All right, so let's write this out just like I did up here with the secant. 1 divided by negative radical 3 over 2. So that's going to become 1 times negative radical 3 over 2. Oh, sorry, reciprocal. 2 over radical 3. And then I'm going to multiply by the reciprocal. Or, sorry, no, I'm going to rationalize the denominator. All these R words get mixed up in my head. All right, so radical 3 over radical 3. This is going to give us -2 radical 3 over 3. And unfortunately, this time we can't simplify any. But this is as complicated of an answer as you will get for the reciprocals. We're going to get -2 radical 3 over 3. And that's it. So head on over to Google Classroom and check out your assignment for today.